So hello and welcome back to the channel. This is Steampunk Quick Tips on gauges. It's not necessarily how they work, it's how we can hack them to make them look like they work. Well, I've got a selection of gauges here which have a variety of inputs in them. And I will also give you some extra nerd points if you can tell me where some of these gauges come from. So, without further delay, let's get on with it.
This video is brought to you by the crushing pressure of reality.
This one over here is a fuel gauge. And the interesting thing is you'd think that this has a mechanical input. A float or some kind of bobber thing on the bottom of a fuel tank directly interfaces with a needle. But spin it around and it doesn't. We just have a series of bolts in the back. And how could this be? This is an electrical input. We have a ground terminal, we have a couple of input terminal, or the voltage, and a signal terminal in there. I might be getting those mixed up, but it doesn't matter because all we're going to do is hack this thing. Now, the nice thing about this one is I found it actually works off very, very small voltages. I believe it's supposed to run on a 12-volt system. It doesn't need nearly that much to run. To at least display something. Maybe if you actually wire it up properly, you might do that. But I have with me here a power supply, and we're going to hook the ground up to ground, and we can touch contact, and there we go. We have movement. So if I clip that off, we can see our tank is reading about half full. And I'm going to go and adjust our voltage. And more. And less. There we go. And if I just take the camera, might have to do this with, I don't know, 2 hands. But if I adjust our fine voltage, you can see that should start dropping off. Just supply a varying voltage between 0 and 1 volt, and you get the gauge to chooch its charge. And that is really easy. This is the next gauge that I'm showing, which is slightly less steampunk, but we can get away with it, I suppose. I mean, it's another type of gauge. And what you can see in here is there are 4 wires coming out the back of it. Now, this one is a little bit similar to the first one in the sense that it is entirely electrical controlled, even though it's a water gauge. Well, this is a temperature gauge, so whatever. But what we have here is a black wire and a red wire. I won't give out any points for guessing where the hell these go, and I just need to turn the voltage up a little bit. This one goes up to about 6 volts before it starts doing anything. There we go. We've hit the 6 volt mark. And it's displaying, which is brilliant, because it's sat in my box so long, I think I broke it at some point, but that's fine. So, that we have 25 Celsius water temperature. And now we have 150. 25. So, what these 2 wires are for, they're your signal wires. And normally, I believe, and some electrician will actually tell me in the comments, please let me know, but I believe you would have a substance which increases its resistance with, or decreases its resistance with heat. A thermal resistor. I don't have one of those. We have a potentiometer. And if I stick any of these legs on here, it honestly does not matter whatsoever. And I could probably tune the potentiometer a bit better. Now we actually get a reading in correlation with. So let me turn the potentiometer. And you can see us getting, there we go, up to its max 150. And we can turn it all the way down, in this case to about 97 degrees. If you change the value of the potentiometer, this is a 5,000 ohm potentiometer. You can probably change the values. I don't think it'll go higher than 150 though, but that's fine. It basically goes anywhere from 25 degrees up to 150, which I think is about boiler temperatures. But still, it's a display. It'll work on your cosplay, which is awesome, and we can control it with a separate knob if you want it. Or you can axe the knob entirely and go for an analog out of an Arduino, and you can get that to display whatever you want. And you can map that to some certain values and let the Arduino figure out all the complex math of it, which is really cool. Next up is probably the more interesting of the gauges, which is this one. And I hesitate to call it a speedometer, but I think it is. It doesn't measure I don't think it actually measures the speed of the wheels turning. It measures the speed of the engine. So it's rev counter, I suppose. That's a better way to describe it. But yes. So this is an interesting one because this one doesn't take an electrical input. It's our first mechanical input. And this one, okay, you have two mounting brackets here. This is a light bulb up here. And then this, which I have kindly stuck an M4 shaft into, and give the M4 shaft a little spin, and you can see the needle flicks, needle goes. So, how do we make this into something usable and easy? Well, boop. There you go. Yeah, this is a drill motor, but it's the easiest motor I could find with the easiest attachment. You don't have to have a beefy motor like this. You can literally have a tiny little 3-volt hobby motor, and by that point, you will be converting electrical current, so anywhere between 0 6 volts, into a readout on this display. It's a bit wobbly, but I can turn the voltage down. And turn the voltage up. And this motor is running off 3.5 volts. And then I can wind it all the way down. And that's running off 1.5 volts. So honestly, this is not a lot of power going through to these. You could run this all off an Arduino. Nice and easy. Okay, yeah, it's a massive motor, but you really don't need it. This is entirely overkill. Like I say, it's just the easiest mounting motor I have for the video. So yeah. Plus, an advantage to this motor, or this gauge, is you can take an output gear off this and have it powering some other crazy contraption Guga. So it does actually measure the output of the contraption you have on top of it, which I think would be really cool. These are the classification that I call pressure gauges. They're pretty much all built the same, regardless of whatever form factor they come in. This one happens to be an oil pressure gauge, but we have this one measuring a vacuum in water, which is a thing. There's also, bar, PSI, whatever it is, but they all have a common guts to them, a common inside working. And they'll be characterized by this, which will be some sort of threaded port on the back. These are just holding clamps, and I'll just have this on the back here. On this particular one, it'll have it on the side, so in there. And these, there's no easy hack to them. Well, there is, but it's a lot harder than these three, because these you just, add something, motor, electricity, job done. These ones are a bit harder. This type of gauge is, I'm not ever going to hack this one, because it's got this rolled lip seam around the edges, and to try and get that apart is a complete nightmare. You end up bending and marring the whole gauge, and it's just nicer to have this like this, and it'll stay like that. Whereas this type of gauge, which is brilliant, because there will be little screws in the sides here and here, and you can pretty much just pull this whole gauge assembly apart like so, and then you can take this faceplate off with a couple of screws in the back, and you can get access to all the sweet juicy guts from inside. And here we have the inside, and this is the hack that I made. So basically what usually happens is you have this thing, this is your pressure gauge, and it'll feed into this block, and then in this block there'll be a tube of copper which bends round here, and then it'll go into a little springomer thing with a rack and pinion mechanism which feeds then into the front of this, where you've got the dial, and the more pressure that builds up inside here, the straighter the tube gets, pulling the little rack and pinion springy thing, pulling on this, and the needle goes up and down. And what we have now is I've literally just sawn all of that off. So there we go, I've sawn all of that off, and literally just, this is in fact glued together. And here's a really cheap, this is a Hobby King servo. But yeah, so you can have the cheapest, nastiest servos on planet Earth. And servos are brilliant because they run off PWM. And PWM is also the language of Arduinos. So you can happily control this with an Arduino. Or in this case, for my demonstrational purposes, I will be hooking this up to my servo tester. So I've got this little guy, which is just a normal servo tester, and these are brilliant. Okay, so these, not only do they test your servos, but they are like the PWM equivalent of these potentiometers. So they're literally another knob. You can do this, and if you want, you can have your Arduino, so you can use this knob to communicate to your Arduino and send that back out to do something else, like changing LEDs or who cares? Arduinos are great converters. But the point is, these things are useful for projects as not just servo testers. They're PWM converters. So we're going to hook this one up. And there we have it. Turn that. And I can get it to display whatever I want at my will. Now, I think this is just a cheap 90-degree servo, so it's not going to go the whole range of the dial. And normally there'd be like 180-degree servos, so... But the point is, like, that's good enough. It adds some life to it, and it gets it displaying a thing. And like I say, you can control this with Arduinos, or really anything. It doesn't really matter. As long as it speaks PWM, you're golden. You can find these type of gauges, which, if we have a look on the back side, you have these little flange tabs, which if you twist it, they line up with these little holes, so you can actually pull this whole ring off. Unfortunately, it's a bit corroded, so I ended up having to bend these tabs off. But what we can do is I can pull that out, pop that there, and then we should be able to dump the frame out. And now you have access to the face and everything. So, if you can totally go further and put the servo in here, and you can drill a small hole in the back to let the wires out, that is not a problem at all. But I'm going to show you on this one a really quick and dirty solution to your gauges if you want them to display something. And that is, you have to go in here, to take the needle out, and we go ahead and put the needle back in. And now we can drive! Or perhaps you would like to... Oh. fair. Or even, you could decelerate. It's nice and quick and easy, this one. You will often have to remove the needle anyway, to get into all the other gubbins. And there's the insides, if you so wanted. And there we have a gauge that is reading something. And you don't have to literally do anything else. I think the only tool I used to modify that was with a little screwdriver, just to pull those tabs up there. And that's that one. And this one, again, there's a couple of bolt holes in here, which then just allows you to pull that up. Nice and easy. Take the faceplate off. And then again, we can pull that needle off. And if you want it to display something, you can just mount it back in there. Nice and easy. Or we can dig a little deeper. And there you have, if the lighting was a little bit better. There we go. Where did the needle go? There we go. There. And that is the gauge that I'm talking about. So this is now for the nerds in the back of the class. So again, here's that copper tube which goes out, and that will straighten up and compress down. So the more pressure you have, the straighter that gets. And that connects in through to this little link arm here, which goes over to this sort of hemi gear, I think they call them, which drives a little pinion in here. And that's the shaft there. And there's just a little spring in the thing just to keep it all together. In fact, I think this tube has its own natural spring to it anyway. I think, to be fair, this little spring, this little coil spring in here is just to maintain backlash or something like that. All very technical. To be fair, it's a little bit over my head, to be honest. But yeah, usually if you want to modify this gauge, I'd undo that, and saw that off there. And this whole mechanism would just come out. And we can go ahead and stick a servo in there and make sure the servo pokes through the hole of that gauge. And if you're here and you've already taken the thing apart, there would be absolutely no harm in going through and sticking a couple of gears and things inside it and really steampunk the gauge if you want. Or modify this faceplate, do whatever you want. But for the minute, I'm just going to leave that gauge as it is. These kind of gauges, so they're dead easy to take apart, dead easy to put back together, dead easy to mod, and they're dead easy to clean up. Whereas these kind of gauges, a little bit, plus they look more steampunk. Although I've not seen one of these gauges with these interesting interfaces on them before. So, there we go.